All right, so continuing on from proving triangles congruent, it moves on to just the next line, which would be our Cpctc. So, and you'll learn in a moment what that means. So, suppose that we know that two triangles are congruent. So, triangle ABC is congruent to DEF. The question then is, can I say that angle B is congruent to angle E? And what I'm going to actually do is, I keep forgetting the three letters, so let me add those guys in there. So, angle ABC is congruent to DEF. So, yes, that would make sense by the definition of congruent triangles, because we know congruent triangles are where the angles are congruent and the sides are congruent. So moving forward, from now on, what we're going to be doing is we're going to be drawing conclusions like saying B and E are congruent after knowing the triangles are congruent. So this is what we call Cpctc. It stands for corresponding parts of congruent triangles are congruent. And you will, though, in a proof, always be writing Cpctc. You're not going to write that whole thing out. Now again, to review, for corresponding parts, what we mean are angles and sides. So the nice thing about Cpctc is that Cpctc is always your next reason after proving triangles are congruent. If you're not proving triangles are congruent in the proof statement, no matter what, that's your next line. So let's just try one of these. So the nice part is it's taking what we did in the previous lesson and we're just extending it one step further. Extending it one step further. So it says we have given that SM is congruent to PM. And we see that angle SMW is congruent to PMW. So that's given to us. So that's our first statement with given. Now, these two triangles, they share a side, which means if they share that side, that is our reflexive property. So MW is congruent to MW by reflexive. Then the two triangles, if we look, are now congruent. We have SAS, SAS. So again, order is important. If we go from S to M to W, we have to do the same thing on the other side. So we have to go from P to M to W. And that's by SAS. And the previous lesson, we would have stopped there, but we're not, because we're trying to prove that SW is congruent to PW. Those are parts of the triangles we just proved congruent. So right after SAS, you write Cpctc, always, no matter what. Nothing should come in between that. And then what are we using by Cpctc? We're saying that SW is congruent to PW because those are corresponding parts of the triangles that we just said were congruent to each other. All right, let's take a slight detour here. We're just going to add one new thing in here. So when we talk about circles, we name a circle by its center. So circle O. Every point is the same distance from the center, which equals the radius. Points A, B, and C, they lie on the circle P. And PA, PB, PC are called the radii. And just continuing with the review here, area of a circle pi r squared, circumference, which is the perimeter of a circle, is 2 pi r. Now, the reason we have to go into this is because they throw this one theorem at us, which is used quite often, which says that all radii of a circle are congruent. So I would just anticipate any time that you see a circle as part of your proof or a problem that you're doing that you're writing a proof, I can guarantee you're going to use that theorem. So let's see. So it says, if we look now to example 2, it says given circle P, so we know that P is the center of the circle, and we want to prove that AB is congruent to CD. All right, so we copy our given down. Based on this information, we got 4 radii, so PC, PD, PA, and PB. And by this new theorem, we can say that all of the radii of a circle are congruent, and we just list them all out. Now, when you list, make sure you're either going from the center point out or from the outside, from the point on the circle into the center point. Just make sure you're consistent about labeling any segments that you're talking about. Now, in order to prove that AB and CD are congruent, we have to prove the triangles are congruent. Well, the other interesting piece that we have here, we have vertical angles. So we can say that these two angles are congruent to each other. So angle CPD is congruent to angle APB because vertical angles are congruent. Again, don't forget, make sure you add the congruent part to it. Don't just write vertical angles because that's not telling me anything about them. You have to tell me they're congruent to each other. Then the two triangles, top and bottom, we have an SAS situation. So CPD, triangle CPD, and triangle APB are congruent by side angle side. We're not proving Triangles are congruent. So again, no matter what, right after SAS comes Cpctc. And that is where our prove statement comes. AB congruent to CD for that. All right, so the nice thing is, the most important thing is you understood the previous lesson, because now everything stems from that lesson. And all we're doing is just taking one more extension and going one step further with it. All right, one final one here. So it says given circle O, so we know O is the center of the circle. T is complementary to MOT. S is complementary to POS. So copy down our given. We have 2 radii. Technically there's 4. If you want to include all of them, that's fine. But we've got these 2 guys in here. So we know they're congruent because all radii are congruent. If you want to include the OK, that's fine. But it's not needed here, but it's still relevant. So if you want to put it there, that's fine. We have another set of vertical angles going on here. So I'm going to put those in right away. It's always best to get all the information out first, and then you see what you have to work with. So we have our vertical angles are congruent. Now we're going to take the fact that we had those vertical angles, and if you look, MOT is one of them, and POS is the other vertical angle. So we now have 2 angles, T and S, that are complementary to congruent angles. So then angle T has to be congruent to angle S. So 1, 2, 1, 2. So again, angle T, now, should we be using 3 letters? Absolutely. So it should be MOT, and it should be PSO. Or MTO, sorry, and PSO. And then your reason, this is my abbreviated version, but it should be, if you want me to write it down here. So if 2 angles are complementary to 2 congruent angles, they are congruent. And then if you